Okay, so welcome to this last lecture of the software testing course. And this lecture is going to be not so much new content for the exam or so, but more to talk about the last assignments and to make sure that you, can finish this course and get a passing grade. So I think we're going to start talking about, we're going to have a sound check first. And I could probably check that I'm using the right microphone. Yeah, it sounds okay. Thank you. Okay, so we are going to take a look at the assignment 1, part 2. And part 2 is single or pairwise student assignments, so you can work alone or you can work in pairs. I would recommend work in pairs. And the reason for this is that the assignment is to learn and write test-driven development code. For this assignment, I would suggest that you read the course literature that is this book. So Test-Driven Development by Kent Beck. And it's a pretty easy to read book, so that shouldn't take too much time. And I mean, you can start it without reading it too, but then you need to find out what test-driven development is. I've given a minimal introduction to it in a previous lecture, but generally it's red, green refactor, 3 different steps. And in this assignment, we are, creating Git commits for every step to be able to trace the process. So this isn't meant to be super strict, but you're trying to get as strict as you can just to learn the process. So you may have cycles of this that are not correct. For instance, in the beginning, when you start out, you may do some mistakes. You're used to be programming in a specific way, and then you just continue programming that way, and that is not problematic. I think it's quite okay to do mistakes like that, and then you just continue working, and the further you go, the better your cycles is supposed to be. Notice the examination of this is done individually. I have we have this may or may not work. Yeah, so we have a booking form for this. So we have 3 dates, the 10th, the 5th, and the 3rd of January, where you can sign up for examination of this. So and this is individually. So even if you worked in pair, you do an individual oral exam. More on that later, right? So in this assignment, I want you to be free to choose your tools. I mean, if you want to continue with Java, you can do that. If you want to try out other languages or other things, but you are responsible for choosing something that you can master, right? So that you already know. So don't start with a new language that you've never touched before. Use one that you're pretty confident that you can work with. The sort of standard tools would be Java, not JUnit 4, but JUnit, what is it called, Saturn, the one that you used for Jupyter, yeah. And then I would say Mockito is probably a good tool, and you should also try out code coverage tool so that you've learned these tools. But you decide the tools, but you're also responsible for these. Okay, so in this, it's a very free and open assignment, so you can essentially try out whatever you want. I would suggest that you start with super simple things, like doing the same thing that you did during assignment 1, part 1. But you're doing test-driven development. So you create one test. Notice that I focus on one test, but because it's very common that students, add 3 tests or 4 tests or something like that. So they fully test something. But you add one simple test, and that is the red. And then you run that test. And if that test does not fail, you cannot keep it. You're not allowed to keep that test. This is allowed is a bit strict. And I want you to try to be strict on this. But if if you made a mistake, you can still keep it, but you should aim for not keeping tests that you can't get red. And the reason for this is that you should not add a test for something that is already implemented. You should add a test for something that is not implemented, and it must be red first so that you know that it will flip back to green. So if you add a test and it's green, and then you add some code and it's still green, you don't know that you did a change, right? So the entire idea is to only add tests that would sort of recognize the change you make in green. Okay, so one test, it should fail to begin with. It is okay to make a test that and I think in the book it says that compile errors counts as fails. So you could, for instance, create a test, and then in the test you're just creating a new class that you have not created. So the test sort of fails because the class does not exist yet. Normally I skip that step, and I add the test, and then I add just automatically generate the class, automatically generate the method that I'm going to test, make sure that the test still fails at that point. And then we would make a commit, and you would put red in the commit message. You can add more words. It's not that strict, but we should see in the commit history, it should see like red, green, refactor coverage, red, green, refactor, red, green, refactor, red, green, refactor coverage. When I look at that, it should clearly show that you worked in these cycles. Okay, then we step to green. And if you're working in pairs, I would suggest that not the same student as wrote the test is actually writing the implementation. So you're sort of playing ping pong against each other, and one is writing the test, the other is writing an implementation. And I would suggest that you do the following, that the student who's writing the implementation tries to pass all tests, but write the simplest possible but not correct solution that still passes all the tests. This way, you are sort of playing a game against the one who wrote the test. So okay, I'm going to write the simplest implementation that passes the test. If you have one test and that test is asserting a specific return statement or return value, perhaps you're just returning that value. And then the student runs the code and see that all test passes. So to pass the green, every test must pass. And this should be quick. It should not be a lot of time spent here. Normally, you just make the simplest false implementation. And the reason that you're supposed to do false implementation is that if you do the correct implementation, you cannot add new tests after that, right? Because then you're done, and then you should not continue. So the only time you're adding the correct implementation if it's simpler to write the correct implementation than to create a false one. So if it's simpler to write the correct implementation, then you can go to green, and then you're actually done, right? After green, you do the refactor, and I just say rewrite the code in the assignment, but refactoring means that we rewrite the code in such a way that we improve the quality of the code, but not just the system code, also the test code. So make sure that that you're actually trying to improve the test suite also. Yeah, of course, after green, you're making a commit with the word green, and then you refactor code, and then you have refactor. You don't need to do very frequent coverage measurements, because coverage is not really a part of the test-driven development. In the TDD book, it says that, I mean, bad coverage is a sign that you're not really doing TDD in this strict manner. So, for instance, if you're writing the correct version of the code, you cannot add more tests. You probably have sort of leaked in implementation that you still don't test, right? So, if you have that case, for instance, you write an if statement and you didn't have a test that would go into that if statement, then you would get bad coverage. But if you follow this methodology, you should get, 100% coverage, more or less all the time. Okay, and you also save the measurement as a file in your GitHub repository. I mean, this is just to be able to see the progress when we look at your commit history, and also to, learn the coverage tool. We get any, as usual, if you have questions, you write those in Slack. Okay, this is a quite difficult assignment. So, and it's very free. Therefore, we have some, I try to make some open rules that can show you approximately the size and complexity that we're after. And I would say that start with very simple stuff, go to more complex stuff after that. So aim to do different kinds of code. That is more important than you do a lot of code of the same type, because we want you to learn how to write tests for different kinds of code. And I've tried to come up with a couple of different situations by writing these requirements, and I'm just going to go through those. But I got a question: should we aim to test the main method of the application? Yes, I think so. So if you can test the main method of the application, yes, you do that. In some cases, you cannot do that. In most of my main methods, they are sort of creating a number of factories and then dependency injecting those factories into the application, which means there's very, very little code in the main method, and everything happens in more private methods or stuff like that, or other classes. So I have tried to have very little code in the main method, and the reason for that is that traditionally it has been hard to test the main method. So if the main method does this, it creates a lot of objects. It's connecting to databases and stuff like that. It might not be easy to test. So if that's the case, then you can leave it out. So as you probably learned in assignment 1, part 1, the main method could be difficult to test, because we need to control the input through, for instance, system in and stuff like that. So I think that might be, still try to do it, but it might be too complex. So instead, we have very little code in it, and then you just start that manually once in a while. So don't forget to test manually just because you're writing TDD code. I've actually done this. I've started a project writing a TDD and just got lost in the TDD process, never started the application, because I was so, doing these small cycles all the time. And then I found out the application didn't work. But I think those experiences have also been good for me. So the minimum requirements, I've said that at least 4 system under test classes, and this is system classes with dependencies. So these should be dependent on each other also. So, and the reason for this is, of course, you're supposed to mock these dependencies and, learn how to test these classes individually without needing to worry about the dependencies. So when I add a dependency, that class is usually empty or a skeleton class. So every public method probably only has public methods, and then every public method is sort of returning 0 or throwing exceptions or something like that. I would suggest it to throw exceptions, and that you say that throw not implemented exception or something like that, just to make sure that you are not starting the application and thinking that it works, but you still have forgot about testing this class that you're dependent on. When you're mocking, you can start, you can, develop one class at the time, even if it has unimplemented dependencies. So again, yes. So if you can, test the main method with automatic unit tests. Thank you for the question. Yes. Okay. You have used dependency injection is the second requirement, and that is, you should inject your dependencies so that you can mock the dependencies. And this is actually the third one, is also you need to mock or isolate dependencies so that bugs in the class under test trigger a failing test and not a bug in other classes. So these in each class should be tested individually, and I mean that all of these things is so that you're actually doing mocking. And I think the problem with testing the main method is that if you cannot really mock these dependencies because you're creating these and dependency injecting the actual dependencies in the main method, this makes it hard to follow this requirement. Okay, and the fourth one is dynamic object creation, and this is in order to learn to create factory classes. So at some point, dynamic object creation means that you're creating objects with new operator at some point in your application. So this could, for instance, be that you're creating an application for a blog, and at some point the user is doing something that creates a new blog post, and each blog post is an instance of the blog post class or something like that. So that would be valid. It could also be, if you're creating a game and you're loading a level, and when you finished one level, you can load another level. That is also creating new objects and creating these. And the problem that I want you to reach is that when you're using the new keyword and some class name, that becomes hard to replace. So in order to replace that within the class, so this is a dependency from one class to another class, which makes it hard to replace that. And in order to do that, in order to be able to mock this dependency, you should have a factory class that is actually doing the new. Usually the factory class is pretty easy to test also, so this is good. So if you're in several places, I've said, just to make sure that you're not avoiding the problem. Not only initial setup is to not only create instances when you're starting up in the main method, for instance. Okay, I want the project to have some user interface. It could be any user interface, console, graphical user interface, or web application. And this is to be able, if you're working with some graphical user interface, you're going to learn that these are probably hard to test. If you're working with a console, you've already touched that a little bit during assignment 1, part 1. So I think that is a good starting point. And I think that is what I would recommend most students to do. But when you've done that and you feel that I know how to do this, I would progress to probably a web application. Make it super simple, just having an API perhaps that the client application is calling or something like that, and then it could be pretty easy to test that too. Okay, so at all points of this assignment, remember that you're there to learn and not to solve things. So you're actually solving things and you're encountering problems, and then you need to solve this. But The thing is that I want you to learn from this. So what I want you to show is that you should know your, unit testing framework, the different asserts and different, ways to do this in the unit testing framework. So if you're using JUnit, make sure that you've used different versions of the asserts, that you've used the parameterized test, that you've tested exceptions. Look through the user interface of the unit testing framework and do a little bit of checkboxes. We've used this one, we've used this one. Assert false, assert true, assert equals, whatever. And look through it. If there's something interesting in your framework, make sure that you use it. The same goes for the mocking framework. So try out different things, try to understand why are these here. And some frameworks are bigger than others, which means that you still need to, perhaps limit yourself some. So if this is a super huge framework, of course, you cannot know everything in it, but aim to do it still, right? Same thing goes for the coverage tools. What kind of settings, what kind of coverage can I get here? Sometimes, you're supposed to generate a report, and I want you to do that because when we automate this in, for instance, generating coverage in GitLab or on GitHub, I want you to explore these things. So learn the coverage tool also. Yeah, of course, you're supposed to know how to test behavior using mocks. And with testing behavior, I mean that you're verifying calls to methods. So we're not only testing return values or exceptions thrown, we're also making sure that you know how to test if a method on the difficult dependency is called or not. And I know in Mockito, for instance, you can make sure that certain methods are called in specific order and stuff like that. So explore that. Yeah, different types of mocking, different types of stubbing. I think one of the things that I want you to do also is if you find something that is hard to test, or that you encounter that you don't know, ask a question on Slack in the public forum so that we can explore these difficult situations together. And because not every student is going to encounter each problem, so by sharing the problem, and since everyone is using their individual code, I don't think that it's a problem that you're showing code to other students. So let's do that. Let's explore these together. And use of coverage too. Yeah. I think small project is something that you should focus on. Write a small project. It does not need to work in the end. So you can have still unimplemented parts. It's very okay. The bigger the project or the more TDD cycles, the better, the higher grade you're going to get. So in the end, during the examination, I want you to have a programming environment with the project that compiles, and you should have almost 100% unit test coverage. Of course, if you have dependencies that you have not yet started to test, these may not be covered yet. So if I have a class that I have only mocked for now, and the class is just a skeleton class, then it's fine to have that uncovered. 100% is the goal, but sometimes impossible. We've had that lecture also. So we are reasonable or I am reasonable when we're looking at this. We should have a Git history that shows that you worked following the TDD principles, the red-green refactor, and sometimes coverage. And I want you to be able to, during the examination, to show how mocking is used. So perhaps we are actually adding a little bit of functionality, something simple. I'm not going to ask you to do something that should require, a lot of thinking, but I will ask you to, perhaps write a little bit of code and show me how to test that during the examination. So it's not enough to have something in Git. You should have the things in your head. And this is the reason that I want both students to be coding and to be testing, so that both have acquired the skills to do this. And I'm going to be kind and nice during this examination, so you should not worry too much. I know some students become very nervous, and I'm going to be, mindful of that. Show that you can find code not covered by any test, so you should be able to run code coverage on your computer during the examination. Show source code and classes and test classes. Yeah, of course. I'm going to probably, if I'm looking at your code, I'm probably going to look at it on GitLab. So make sure that it looks nice on GitLab. Okay, I've also created a number of questions, and every one of these questions you can ask. If you're not finding the answer to this question, we could discuss it in Slack. It's fine. And you should be, prepared so that I can ask you the same question or something similar to these questions. So don't settle for the exact answer. So what is a unit? Okay, that could be answered by many things, right? It could be a method, it could be a class. So maybe I'm asking, could a unit be, could an API be considered a unit or not? Or something like that. Yes. I think I've set up 30 minutes Zoom calls. So you should need a headset and yeah, things like that. Yes. So I'm gonna, measure you on different things and put a value on you, and then that should give, end up with a grade. Okay, I think that is assignment 1, part 2. Are there any questions on this? Yes, these are 30 minutes. I might need, 5-minute break or so in between these. So assignment 2, hopefully you've done a lot of work on that already. And I've got a number of questions on it. And some students have asked me if they can have an open source project like a library or an API that they're testing. So, and yes, you can. You can look at such a project, but some things may not exist for every project. And again, assignment 2 is about, learning how other people test their code. So make sure that you are learning what you need to learn, and not every project is suitable for learning everything. Like in the library or an API is not suitable for manual testing, for learning manual testing, because it's not going to have any manual tests. It might be very suitable for, learning how to write tests for a library or an API. So make sure that the sort of project you're looking into and the way that you want to learn testing matches. Yes. And I think that this requirement is important. It must be executable and functional for you. So if you're testing a library or an API, you should be able to write code for that library or API. If the project is too small, I think that was the most problematic things last year, where the students were trying to avoid getting too much to work. And then they were limiting their project size, and that is, I think, the wrong way of doing it. Instead, they should limit what they're looking into the project instead. So try to have projects that are really good on testing to learn from, because if the project is not good on testing, you're not going to learn anything useful. So I got a question on A1 part 2 is only for higher grades. Yes. So if you've done and completed A1 part 1, I am more than halfway through checking assignment 1 part 1. So if you get approved on assignment 1 part 1, you will get an E as a grade. If you're also doing assignment 1 part 2, you can only increase that grade by doing that. Yes. Okay. You should be able to run existing tests, understand their purpose and fundamentality. So if there are automatic unit tests in this project, I want you to be able to run these. There might be some problems. I mean, you might get some tests that you cannot run for some reason. There might be some branch that the development branch might not be working fully. You may run into any problem really. There might be difficult dependencies, versions, and stuff like that. And if you spend all your time, working on these problems, I would suggest to swap project pretty early. But also these skills of getting a project starting, getting the environment set up it's important skills, even if they are not about testing. So try not to avoid it completely either. But spending 4 hours on getting it set up and get the test to run and everything, I think that is fine. Spending 20 hours is too much time. So then it would be better to find a more mature project that perhaps has good instructions on it. So I got a question on A2. How many pages do you expect us to write? So for passing grade, you should essentially have a presentation that shows that you fulfill these things during the mandatory requirements. For the higher grade, I also want you to have more stuff. So in order to give judgment on the quality of test, perhaps you need to write a little bit on these. So I would suggest have all of these things under the mandatory requirements and higher grade requirements as some kind of headlines in a document, and then you write what you need in order to do this. So there is not a page limit. I would prefer not to get 60 pages. I would prefer to get 5 pages to 60 pages. But there is not really. You do when you explore the project, you write. So when you find something, oh, this is cool, or we don't understand this, write that during one of these headlines. And then the higher grade you want, of course, things that look better get higher grades. Of course, it's like that. I mean, if I get a very nice report, of course I'm gonna look at that. Oh, that looks really nice, and then become happy, and then I think this is really good work, because that's how the brain works. But really, I'm not after that. I'm after you working on learning things. So you should show that you've learned things and thought about things, and explore this project. So I would prefer that you focus on learning, and then the document that I'm getting is a product from your learning more than a report. So yeah. Yes. So take some screenshots when you do stuff, and write some. Try to make sure that you also explain to me under the screenshot what you're seeing in the screenshot. Okay. Yes. So you will be handing in your documentation in an online form during the workshop on the 4th, I think it was. Is it okay to link a GitLab repository? Yes. Yes, sure. You can link a GitLab repository. Make sure that in the README in your GitLab repository, if you do it this way, that I can find everything important. So if there are many files, show me a map, so to speak, in your README file. So here are my presentation. Here is my our diary of this. Here are the exploratory tests. Here are our tests that we have written, so that I can find all the things that I'm looking for in the requirements, both the mandatory and stuff like that. So for passing grade, I want you to have a presentation, and the presentation should be aimed at other students. And you don't need to show everything when you're actually doing the presentation. You can sort of skip things that other students in your group have already covered, because you are supposed to make learning experience for these other students. So then you can skip slides that are not interesting, or that you think is not interesting. But to me, I want to be able to, look through your slide and see, yes, they have, a description of the project. They have thought about the testing strategy in this project. They have run the test. I can see a screenshot of that. They have maybe done some exploratory testing, and they come up with some conclusion on that, right? So that is sort of the things that I'm gonna scan your presentation for. But when you're doing the presentation for the other students, I might not be in the group, so you focus on giving them something. So for instance, if you've had a specific testing framework that is really cool for testing user interface or web application or whatever, or that they mock in a specific way, then you talk about that. Show them one of their tests and show them what you found was interesting in this project, why you chose this project for showcasing. Yes, so on the 4th of January, you're gonna have, give a presentation. I say 5 minutes of content, but you have 10 minutes to give that 5-minute presentation. And the reason for that is you might need some setup time. Perhaps the previous student needed a couple of more minutes and stuff like that. And so you have 10 minutes time. And then the group is supposed to ask follow-up questions. And you have 10 minutes for that. So when you're listening in, okay, reconnect with your own project and ask questions like, okay, in my project, we saw this. Did you also see that in your project? And things like that. And during that second 10 minutes, so 20 minutes per project totally. During the second 10 minutes, you might need to show the project a little bit to the other students, and then you discuss the project. Then you compare the project with each other. So make sure this is student-driven, and your responsibility also to create the workshop that you want to be part of. And I know many students think that presentations are, horrific and stuff like that. So I'm gonna prefer to have a bit smaller groups so that you can feel comfortable presenting in these groups. And then I will step into these groups during the workshop and try to spend at least some time in each group. That is my plan. But I may not see everyone's presentation. But it's going to be mandatory in the sense that I'm going to make sure that every student is there. I'm going to make note who was there and things like that. And then I'm going to trust that everyone presented and did their best asking questions also. So I would say like this: during the 10 minutes of asking question on some other student's project, make sure that each student in the group ask one question. If you run out of time, that is fine. Right? Maybe if you have been asking questions for every presentation and there are some students that didn't ask question, make sure that, okay, then you can sit quiet during the next presentation and then they can ask questions instead of you, right? So everybody gets some screen time. Okay, I sometimes get questions, can we investigate this project or this other project? But I think this is up to you to find an interesting project. So I want you to explore different projects, search for projects, think, is this a good project or not? So if the project turns out to be a bad project, you can still keep it, but then you add some other project that has the quality that you're looking for. So you can look at more than one project. Perhaps you're looking at 2 projects. The first one you maybe only had unit tests, and then you found out that they really didn't have a test plan, that the unit tests were badly written, or they have really bad coverage or something like that. So you're sort of exhausted the possibility of learning things from them. And then you take a look at or compare with another project. Perhaps you're selecting a project that has manual testing just to get both parts. During your presentation, you can, give a little bit of both or just give something from one of the projects. Since it's just 5-minute presentation, you don't have time to cover everything. Yes. More questions on assignment 2. We need a break, so let's have a break. Okay, so we're starting again, and we're going to talk about assignment 3. And I might need to retcon things that I've said before, because I realized that I have mixed up, last year's and the previous year's instructions for this. So I think we're going to follow what is said on the course homepage, but we're going to maybe allow students who have already done stuff because of my mix-up to, continue to live with that. Okay, assignment 3 is to dive deep into a specific subject of interest and read a scientific paper related to testing and present the results of that paper. So this assignment has 2 purposes, I think, and the first one is, dive into some research in testing and get to know a little bit on that. But the second thing is that you are supposed at some point to write theses, and I want you to, get starting preparing for that. During the thesis courses, we have, some parts of that dedicated to these skills in order to search and evaluate scientific work. But I think it's too little, and therefore I want you to, preparing already for this. It's also the case that there are a lot of cool research out there, and I want you to, as students, explore that and be able to, learn from such papers, learn how to read them, how to extract stuff from them. And as a student myself, and then as someone who wanted to implement specific algorithms, for instance, and some of these algorithms are only described in these articles, and they may not be open source implementations of these things. So, for instance, if you're going into machine learning and stuff like that, a lot of the, the common algorithms are already implemented, but the newest ones, you can only read about this, and they might be closed source. But you can still, implement these by reading the scientific paper about them. Okay, there is a couple of goals from the course curriculum that you should individually present and explain a specific study area within software testing and demonstrate theoretical insights in that area, and critically evaluate literature and other information sources in the field of software testing. And then I've interpreted that as this assignment. So you're doing this alone. So don't pick the same paper as the student that you've been working on for A2. Show that, you picked another study. And I think all of the things in this should be done alone also, so that you get the skills in order to do this. So what you're supposed to do is finding one peer-reviewed article. Sometimes articles are called papers in the science community, of a subject of interest in the field of testing. This field of testing is software testing, which is a subfield of computer science. So computer science is the overarching area, and field of testing is, software testing within that. So we don't have a paper on, manually testing hardware or something like that, because testing are in many different fields, but we're looking into software testing, right? So we were interested in software, which is the subject of this course. So it must be related to the subject of this course. It should be peer-reviewed, which means that at some point, in order to be published, there was a publication process where some researcher wrote the paper, sent it into some board for reviewing. And this board was probably consisting of other researchers also within the field of testing that read the paper and said that this is a good paper. And this is the quality control of research. So there are different venues where researchers can send in their research, and these venues can be different books, which are called journals,
or there can be conferences, which are opportunities for researchers to meet other researchers. And there are a number of these journals, there are a number of these conferences, very many. And for every part of computer science, there are conferences, and then there are journals. Sometimes the journals are very general, so there are these journals that cover the entire field of computer science. Other are more specific, journal on software testing, whatever. The same goes for these conferences. Usually, the same researchers go to the same conferences over and over again. So they build up communities of researchers. And these communities of researchers, they discuss their research during these conferences. And they also build up relationships so that they can do research together. So this is, how research is done. Some conferences are stricter and better than other conferences. Some journals are stricter and better than other journals. So some journals are very, very strict, and everyone wants to be able to publish into these. But in order to be published there is this super strict peer review process. Perhaps there are like 5 other researchers reading every word of the article that these researchers sent in, and they are critiquing it. So they're trying to find holes in your arguments. They're trying to, find out, is the information in this article the truth, or sort of approaching the truth? Are they considering every possible angle? Are they writing in a good enough manner? Are they using a scientific methodology or not? Did they think of everything? So these can be very strict to very loose. So even if something is peer-reviewed, it doesn't mean that it is really good. So I've sent in a number of articles myself, and sometimes you get really, really good reviews. So they have really read your paper and, given feedback on your paper. And then you need to change things, and perhaps you're not getting published at all. Sometimes you only get published if you change things, the things that they say. Perhaps, you didn't think of this paper in your related work or whatever. Or you should explore this angle before you publish this paper. But peer review process is still, the way that these articles get approved or not. And when they are approved, they get published. And so this assignment is about finding such an article, make sure that it's peer reviewed, and you should make sure that it's peer reviewed. And you should, take responsibility for that. So some students ask me, can I look at this article or not? But the task is actually to find out yourself. So usually I just ask them back, is it peer reviewed or not? And then you need to find out. And I'm just going to give you some hints on doing this assignment now, right? So there are a number of search engines that you can use. We have one on Linnaeus University called OneSearch. And I usually don't use OneSearch myself because I think it's too limited. But this is a search engine for published work. These search engines can find papers. So if we write unit testing here and we search for that, we can find something regarding to unit testing here. Diversifying focused unit testing for unit testing. So, and this could be interesting. So if I'm interested in the title, then I click on this. And usually I try to write or read the abstract of it. Here it's in Swedish called beskrivning, but the abstract. And if I'm still interested, I download the paper and read that one. Usually I go to Google Scholar myself and search for these. And Google Scholar, the advantage of Google Scholar is that it covers most of the different venues, but the drawbacks it's that it's covering too much. you can see something shows up over here, this dialog, and it's because I have Lean Library plugin installed. And in order to read some of these articles, they are beyond paywalls, and the library of Linnaeus University helps us to get access to these articles. So I'm just going to show that. So if we go to this link, and I'm switching to English, there is a library access plugin called the Lean Library Access plugin that you can install into your browser. I have it over here installed, and that should give you access to stuff even if you're not on campus. If you're on campus, this and connected to eduroam, this should work by itself. Now it seems that there is some problem for IEEE articles, and not sure why that is, but library, if you contact the librarian, you can actually do that through the university library's homepage. You can get help with that. There are search engines like ACM's search engine that you can still get access to, I've heard. You could also, write in Slack, and maybe someone on campus can help you, download the article and give it to you. But on Google Scholar, so unit testing. Usually, I would just pick some topic like unit testing from the lectures, and then I would look into the search results here and see if I find something that is interesting. So, a survey of unit testing practices. Survey is a specific methodology, but I could, go into this and look at this. I would suggest this one was from 2006. It's a bit old. I mean, it's 18 years old. Something like that. Almost, right? 17, no, I don't know. Yeah, but again, we read the title first. If that sounds interesting to us, we go on reading the abstract. If this abstract still sounds interesting, then we can start reading the article. I'm just going to go back. I would suggest picking a date that is pretty close to today. So read an article that is, within the last 5 years or a couple of years, because the field of research changes a lot, and there are, ebbs and flows in different subjects. And if you're reading something that is really, really old, I mean, that could still be valid, but it could also be not interesting. So pick one article that seems interesting. So we're going to continue looking at this. So yeah, so let's pick just the first one here. And you can see IEEE Explorer shows up. And then I want to find out the venue of publication. So we can see, let's see, the publisher is IEEE, the conference location. So this is a conference paper we've learned. And then I want to find out which conference is it. And I can see published here, 2021, IEEE Conference of Software Testing, Verification, and Validation, ICST. So we can click on that link also. And sometimes it says that, directly here that it's peer-reviewed. Sometimes I need to search for ICST, it was called, right? And I click on the link of the conference, and then I search on this homepage for their peer review process. We can just look at attending. Oh, sorry, now I clicked on sponsorship. Track, organization, search. Well, essentially look for peer review process on these pages. If you cannot find anything, look for another paper. Sometimes the publication process is described here. I want to look at different things. No, I don't find it. I don't want to spend time on this, but you should spend time on this until you find that it's peer reviewed. One nice thing with OneSearch is that in OneSearch you can do an advanced search and you can click in that you want it to be peer reviewed. So that is what I feel of that. I think, or so I've heard, but I didn't find it. Okay. Examination criteria and artifacts. So I've written a number of questions here. And these questions are written on the generic way of that scientific articles are written. So usually these articles are describing a problem or some kind of research gap, which means that previous research before this article was written did map out some research already done, right? And then these researchers found some reason for doing their research in this space. So that could be a problem. Like, okay, we want to creating unit tests take time, and we want to automate part of that process of generating unit tests. And then that is the problem that they're describing. They're describing some kind of, some kind of issue that they're trying to improve, right? Or some kind of knowledge that they want to improve on. Okay, by doing something, they improve the knowledge on this topic. And then they should describe some kind of research methodology, how they did what they did in order to find out more on this problem. And then when they've described how that was done, they should get some result of doing their actions. For instance, perhaps they did an experiment. So the problem was something, and then they had used a research methodology like the experiment, and then they did the experiment and that got some results. Perhaps they let students program in a specific way. Some students perhaps programmed in a TDD way. Some students were just writing normal unit tests after writing the code or something like that. And that is the experiment. And then they get results from that. Okay, students that did write with TDD took 50% longer time than the students that didn't. That was the results. And then this word here, validity, is interesting because that is the word that describes the quality of the research. So how good research was this? You should find this word in these articles, validity or liability or things like that. And I think that if we look at validity on Wikipedia, I think this is a good way of learning the word. You're going to find out there are many types of validity. And perhaps some of these internal validity, external validity, construct validity, content validity, whatever here, could be showing up in the paper. And then you find out, okay, what does this word mean? And then you try to read the paper using that knowledge. So in research, they have specific words that have a specific meaning, and validity is one of those. Validity means, is this research valid or not? Can we trust this? Can we generalize from this? Can we, does it mean anything? So for instance, let's say that we try to make research on, professional programmers on their use of test-driven development. We want to learn, is it saving them time to do that or not? If that is the problem or the knowledge we try to find, but we have a methodology where we're using students. So let's say in order to find out about professional programmers, we're using first-year students and we let them program TDD after giving them a 10-minute introduction to TDD. Hopefully, by just saying that, you realize that this is not a good methodology. These students are not professionals, so we cannot generalize from the results from them to the professional programmers. If they only get 10-minute introduction to TDD, and some of you who have started assignment 1 part 2 know that, this takes time. So that is not good enough. So the validity is low of that kind of research. Okay, So you should think about, okay, what could go wrong here? But this is already also preparing you for your thesis work. So learn what validity is in order to, be a better student at later point. Okay, does the research solve the problem and answer the questions or not? Sometimes it does, sometimes it doesn't. And I mean, that is what research looks like also. So sometimes researchers fail, but they still publish their results, and they should. There should be some kind of description of future work. What do they think should be done next? Okay, we found out when investigating with students that TDD takes a lot more time, but in the future, we should look at more professional programmers, something like that. And lastly, something from you. This assignment, I think, let's look at the deadlines here. 5-minute presentation during a workshop. I've actually said that you should be able to record a video on this also, right? Because that was 2 years ago, students were recording videos. Last year, they were presenting during a workshop. In my head, I mixed this up. So I think like this. If you feel confident enough to do 2 presentations during the workshop, then you do a presentation during the workshop. If you want to prepare for that presentation by doing a video, then you do a video. And then if you feel nervous during the workshop because you've already done a presentation of assignment 2, then you can play up your video or send the link to the other student and they play your video. And I think this is a nice way because during the workshop, then you can also, in these small groups, you present A2 and you also present A3. But you only required to do 1 presentation if you choose to do a video. Sounds reasonable? Yeah. I myself would be, very nervous of doing 2 presentations. So I think we're going to do it like this. We're going to have really small groups, and then we only have 2 hours, right? So you're going to, during the first hour, do the first presentation, and then during the other hour, you're going to do the other presentation, and then you're done. But this is just going to be really small groups so that you have time to listen to all this. Probably 3 students in each group. Something like that. Sounds reasonable to me and also fun. Something 3 or 4 students each group. It's just a pass-fail thing. We want to make sure that it's a peer-reviewed paper, so make sure that you found out this paper was peer-reviewed. You want just you to have a critical standpoint, look into this validity. You should, have read something that was scientific and show some theoretical insights. And you show that by being able to present this. Finally, the final exam of this course is supposed to cover the book and the lectures. So you read the book and the lectures. And actually, there are more course content like the external resources here that is also supposed to be covered here. I think the focus of it is the book and the lectures. But there might be a question like on exploratory testing or agile testing or something from these others. So look through these, but focus on the lectures and the book. It's going to be a multi-choice exam online. You're going to have a limited amount of time to do this. It's going to be like this. There are going to be, a headline for each question, and then there are going to be different alternatives. These are going to be randomized, the alternatives. So there might be, 6 alternatives that I've written, and maybe only 3 are showing. This means that there could be 3 alternatives showing that are all false. And in order we're going to do this in Riddler. And don't think that one alternative must be correct. Consider each alternative separately so that, you don't fail just because the correct answer or the correct one was removed. It could be that all 3 are, true. So consider each alternative, each checkbox individually. In order to check no box, you need to check one and then check it out. After these, I think usually 40, it will be 48 minutes or so, 16 questions, 48 minutes. Then you have an option to comment on questions that you got wrong. And you're going to comment in this way. You need to be right in the way that you check these in order to get an extra point. But there might be situations where your interpretation of the alternative is correct, even if I have not marked it as correct. So there might be context, for instance, where something is true in one context and false in another context. Yes. So just because you're, during the commenting, looking up the answer in the book and writing the answer from the book is not giving you an extra point. You need to check it correctly. Yes. Should we submit a written text or something for A3 apart from the presentation? So if you're just doing the presentation during the workshop, then you don't need to submit anything. Yes. So I think I will have a form where you submit which article during the workshop also, right? So if you're missing the workshop, then you could do a video presentation for that one, after the course. Okay, I just want to give something from A1 part 1 before we close this. So I've written a number of feedback items and on this. So first, in A1 part 1, I think I have 20 more students to check or something like that, but I've checked 40 students or so. So these feedback items are from, I've tried to collect as much feedback as possible from different students. So it's not from each and every student. And even if you have done something so to say wrong according to this feedback, you might have gotten an approved score on the assignment. It's because I thought it was good enough that you did what you did during assignment 1 part 1, and it's only for E grades. I'm pretty forgiving in the way that I want, but I still want to give some feedback because I'm not writing individual feedback to each student. The first thing is that I want you to balance the number of tests written depending on the complexity and the size of the code that you're testing. So for the first sum test, a lot of students have written like 7 test cases, but the number of tests and the number of lines of code and the complexity of code must match. So for just one line of code, like A plus B, I would probably just have 1 test case or 2 test cases at most, because it's so simple code that doesn't really give anything to write more test cases. Just for the sake of the conversation, GPT-3 does not agree on this because I've discussed it with the chatbot there. And it says, oh, you need at least 4 test cases for this, because it really wanted to test the edge cases and stuff like that. But generally, more complex code, more test. Less complex code, less test. We want an easy backpack of tests to carry around, because all these tests are going to be needed to be maintained, and programmers are supposed to read and try to understand those. So it's better to have a few good tests than many bad tests, or many tests with a lot of duplication. The less duplication you have in your code, the more dry your code is, the more tests you can have without anything. So if you're using parameterized tests in JUnit, you can have many test cases without adding any cost. Okay, so I think that if you have similar tests, you should refactor these into 1 test. But if you're refactoring things and you lose things, like the naming of the test is actually a description of the requirement that you're testing, so you want to have an executable specification by writing tests, then you may want to keep the name of the method, the test method, because it's giving something to the future developer. So keep your test suite small and powerful. I just want to show that, and this is from some student, but we're not going to say who it is. I would usually not write anything in the assert statement, any string in the assert statement, unless I'm adding information. Instead, I would improve the name of the test method to include the information, so that in the test report, I can read the name of the test case and find out what is this test case testing. When you're writing test data, that means what you're inputting into your methods, or you're inputting into your system under test to control it to run something. Try to minimize that. So if you have really, really long arrays as input, that becomes a test that is hard to maintain. So unless you're testing you're specifically testing, I want to test a really, really long array, try to keep it short. I would say a long array for most code is 3 items. That is good enough for, But if you want to see what happens if I have 100 items in an array, of course you're generating an array with 100 items, and then you call it testing really long arrays or something like that. I would say that be mindful of the work that you do. So you try to reduce the work done, and you do that also by refactoring. So you reduce the code written, the length of your tests, and the complexity of your test by writing smarter tests than writing longer tests. And again, parameterized test and refactorings, or extracting a test-specific private method that you create your own assert method by collecting what is common between many test cases into one private method, and then you call that method from each of your tests instead, is a really good idea. The naming of the tests. I know that in assignment 1, part 1, Tobias wrote these test cases as test something. I want to have it like the method name sum, and then should, and then the kind of stimuli or the kind of controls that you're doing, like should add numbers, should add positive numbers, should give a positive result or something like that. So try to follow that and try to be communicative of what you're trying to test. Yes. Try to have abstract names of the test, so you're not writing your actual input and actual output in your test, but the kind of angle that you're testing. So abstract a free into a positive number when you're writing the name of the test case. When you're mocking, I would suggest use a mocking library. I've encouraged you to use, write your own stub classes, because it's good to understand how these mock libraries, what they are saving us, but also explore these mocking libraries. So take a look at this. Don't stick with writing your own test stubs yourself forever. Instead, do it once and then go into Mockito or something like that. Yes, when you're writing your report, use good tools and to improve your language. I'm myself using Grammarly, and but even if you're writing a report or something as Markdown, copy the text that you have into Word and make sure that it's clearly written in that it's spelled correctly, and that you have good head levels, and that you use full sentences with big letter in the beginning and a dot in the end. And just because I've written that, I've misspelled observability afterwards, right? So I'm not fully working. But let's do that. Okay, so yes. Yes, so I was thinking in this assignment 1, part 1, some part of it was to suggest to the future developers. And I think that recommending an action when you find a requirement that find is unclear. I think this was something that was missed for many. As students, we are not used to be critical against our teachers. So I think many students might say that, oh, what I got was the truth, and I'm not going to criticize the truth. But I think that start thinking for yourself. Me as a teacher make a lot of mistakes. So don't think that you're stupid and I'm the one that is always correct. So start thinking, critically. And if you find something that is unclear, trust that you're correct in that this was unclear. It was unclear to you, so it was not a good communication to you. So, you could suggest a rewriting of this requirement or something like that. And this is the validation part of testing, where you are looking at the requirements and you think, is this the correct requirement? And in the assignment, I think the biggest thing on this was, it was very unclear when it came to its requirements. Specifically, the names, I think, had some unclear requirements, like some characters should not be there or something like that, but it didn't specify which characters and why these characters are. But if we're thinking about what are names, what kind of names, what languages should we allow characters to be in? In Swedish, are we allowing Swedish names? Like Östen or something like that? Maybe we should, Usually when you're stubbing or mocking, you don't want your stubs or mocks to print anything. When we're running tests, we usually just want the test report from it. So don't system out anything in your test. If you're systeming out stuff during a test, it will create, a long log that some developer is going to look at, and the developer is going to think, do I need to look at this? And maybe they are spending time just scrolling through all the system outed things from all tests. And imagine if you have like 100 tests and everything is system out, it's just going to scroll through. And suddenly, if there is something, debug thing that the programmer is adding a system out in order to debug something during the test, they are going to need to specifically look for that in this, mess of system outs. So try to reduce everything that is system out during the test runs. It also consumes some resources if these tests are supposed to be really fast. So tests that don't system out are faster than tests that system out. If there is a limit, and I think specifically for the name tests here also, if there is a limit, like 3 letters should be, I don't remember actually what the limit was, if 3 letters should be allowed or not, but try to have exactly on the limit, and then the invalid part, like exactly below the limit. So if 2 is exactly below allowed characters, have a test on 2. If 3 is the allowed, have a test on 3. Therefore, you're on both sides of this limit. So I think that is the most things that most students would need from this. So thank you for listening to this meta lecture on assignments, and I look forward to see you after Christmas. I wish you a very happy Christmas, and we're going to have, in a number of minutes, some tutoring on where you can join a Zoom call. And yes, but I think that it's going to start 10:30. Thank you very much for listening. See you. Merry Christmas and Happy New Year.